Okay, so as we've discovered, the A and B values there were 4 and 2 respectively. So there's my function there. So we type it in. Well, it's almost my function, except we should have cos pi x on 8. Now, I've decided, reading the question a little bit further on, we're sort of looking at the first 24-hour period. So I'm going to put 24 at this point in time. Maybe we'll need to change it a little bit later, okay? So how much time elapses between each low tide? Well, if we go to our graph, tab the graph, there's our graph there. We've got a sketch of it. And if I analyse my graph, there's a few points there I'll get rid of. We can see the maximum value. We need to find a minimum value perhaps here and here. So let's go to analyse the graph, find the minimum. Fortunately, we have got nice exact values, so that's good. Menu, analyse graph, minimum again. Let's come this side. So it's basically 0, isn't it, at that point? End point up there at 24. So there's my graph, all right? So what do we need to do? How much time elapses between each low tide? So from low tide to low tide, it's going to be 16 hours, isn't it? And that's the same as the period of the function, which you can work out by doing 2 pi on n. So we've got 16 hours for part B. At what time is the low tide during the first 24-hour period? Well, initially, it's at 0, which is what, midnight? Now, I reckon there's a mistake in the question. We'll stick with Monday midnight, okay? So Monday at midnight is 0 hours, and then the next low is 16 hours later. So what's 16 hours later? That's going to be 4 o'clock in the afternoon, isn't it? So Monday, 4 p.m. will be the other low tide. What time is my high tide? We can see from the graph up there it's at 8. So what is 8 o'clock? So that's going to be 8 a.m. Monday morning during the first 24-hour period. And actually at the 24-hour mark, which is what? So that's 24 hours later. So that's going to be midnight. What is it? It's midnight Tuesday, isn't it? So midnight on Monday is Monday evening midnight, isn't it? So those answers aren't quite right, I've been saying. So we're starting Monday at midnight. So previously, it's going to be 4 p.m. Tuesday, midnight Monday is the thingo, so it's the next day that our times are. And 24 hours at T KIlda 24, that's going to be midnight Tuesday, isn't it? So for the final part there in part D. The posts are 8 metres tall above the sea level. How much of the pole is exposed at 2 p.m. Monday? So this is where I think it's a mistake. I think that 2 p.m. Monday should be 2 p.m. Tuesday, because we don't start until midnight Monday. So 2 p.m. Tuesday is 14 hours later. So that's the same as T equal to 14. So let's go into our function. And if I put f1 of 14, I get 4 minus root 2, which is approximately equal to 2.585. Now that's how deep the water is, remember. So this function tells me how deep the water is. So if I have an 8 metre pole, 8 minus 2.58 is 5.541 metres showing, okay? What about 9 a.m. Tuesday? So 9 a.m. Tuesday is 9 hours later, so I'm going to arrow up. F1 of 9 equals, whatever that is, control enter, 5.84, so that's how deep the water is. So subtract 8 tells me I've got 2.15 metres of pole showing. Okay, so that's how we make use of our technology in all of this. Over the years, the pier has been falling apart. It's in desperate need of a new coat of paint. If the council wishes to paint the top half of each pole, how much time will they have to complete this job on Monday? So in other words, the water has to be less than 4 metres deep. So let's find out when the water is 4 metres. So I want to solve f1 of x equal to 4 for X, okay? So that's when the water is 4 metres deep, okay? So if we compare that with my graph, which one's the graph? This one. So 4 metres at X equal to, what were the answers? 4, 12 or 20. So if I trace my graph, let's just do a little trace. So that's nearly 4 there, isn't it? 4.2. All right, so if I want to get it to exactly 4, I could go to my trace, trace step. Instead of making it automatic, I might decide to go up by 0. Or even if I just make it 0.2 will do. So now so let's get rid of that point there that's on the point on the curve. I'll get rid of that one too. So now let's just go back to my trace, graph trace. So scroll down to 4, you can see the 4 there like that. If I push a little enter, it gives me a 4. Now let's scroll to the next point where it is 12, which is also 4, isn't it? So you can see there that as long as the water is under that line there, okay, so if it's from 0 to 4, and then from 12 around to the next point, which is from 12 to 20, I think, from memory, we can always trace. Can I still trace? I can. Yeah, so that's really just confirming the values I got with my solve. Don't forget, I only get nice answers here because it happens to be an exact. So when is it below? I've got from 0 to 4 hours, which is 4, and then between 12 and 20 hours, which is 8. Therefore, I've got 12 hours to get some painting done. Okay? Sketch the graph. Well, here's my graph here. Sketch the graph on the interval 0 to 24, label all the relevant points. So you can see I've got all the key points covered here. Let's say that end point wasn't there. Can I get rid of that? If I need to find my endpoints, menu, in this case, I guess in this case it works out it's because it's a maximum. If it wasn't a maximum, I just wanted to know an endpoint, I've just got to work out what F1 of 24 is, which is 6, F1 of 0. So they're my two endpoints. So at 0, 2 and 6, 24, I can sketch them on and label, okay? So just get the general curves. I've got no intercepts, so I just need to put the relevant points and my minimums, my maximums and my endpoints, all right? During a 48-hour period, determine the intervals in which the tide is receding. What does receding mean? So receding is going down. So if I look at my graph, here up at 8, the water is 12 metres, the water is 6 metres deep, and then it's going down all the way until at 16 it's 2 metres deep. So from 8 o'clock to 1600 it's receding. Now this is one where, okay, my graph doesn't go far enough, does it? So if I go to tab, tab up there, so instead of 24, what if I change that to, what did I say, in the first 48-hour period? I'll make it 50. So it goes longer. Now I'm going to have to change my window. Instead of going to 25, I might go to 50. Okay, and you can see from here, from 24, well that point there, it's going to be the period later. So it's going to be, what did we decide our period was? 16, isn't it? So this point here should be 28, but if you want, we can analyse the graph. Let's get a minimum value. There it is there at 32, so 16 hours later. We can get a maximum value, analyse the graph, maximum up here, and then we'll get another minimum value. Oops, what happened there? There we go, there's our minimum. So we can see that it's going down between 8 and 16. That's going to be 24 to 32 and 40 to 48, which is the period, so that's okay. All right, so that's the period of the time it's going down for. All right, so that's that question.